Welcome back to the beautiful session of Namaganit. Have you ever wondered how to describe a triangle in the form of an equation? And it's a question which was asked by one of my students in the class, and that's so crazily beautiful, right? Isn't it? It's a question that seems deceptively simple. In two of the videos, or maybe I'll try to cover it, but since all of you are into J preparation, so I'll just give you the reference to those which is more useful for JE. Okay, so with regard to those, I'm going to explain this beautiful concept. So for certain angles, this is a straightforward. For example, if you plot a graph of, let's say, mod x plus mod of y plus mod x equals 1, what do you feel the graph will be? I would request you to draw it by your own, because it is perfectly in sync with your JE preparation. So what we can do is, let's put first y equal to 0 to get a feel of the graph, and that forces it to be 2 mod x equals 1, which will give mod x equals half, and which translates to x equals plus minus half. Okay, so far so good. So I know on our x's we have got 2 points, one is half, there is minus half. By the way, it's symmetric with respect to x. It means in this equation, if x comma y satisfies this equation, let's say it belongs to this equation E, if I call this equation E, then definitely minus x comma y 2 belongs to equation. So that shows if I have some point, let's say half comma 0, which is a part of this equation, so that forces minus half comma 0 to also be the part of equation, right? So far so good. So it means if I can just draw the graph for x greater than 0 and reflect it along y-axis, our work will be accomplished. So let's go back and try to plot the graph for x greater than 0. Now for x greater than 0, the first bracket will be open with x plus mod of x plus y equals 1. Now we have got two cases. So we'll take case when x plus y is greater than or equal to 0 and x plus y is less than 0, right? So we have case when y is greater than minus x and y is less than minus x. For x plus y greater than 0, again we can open the mod as follows. This quantity will be non-negative. So x plus y equals 1, which gives a straight line to x plus y equals 1. But remember, this line is under this Gaussian. So let's plot y equal to minus x, and here we go, y equals minus x. So for x plus y greater than 0 will be somewhere on the upper side of this graph. On that side, our equation tells like 2x plus y equals 1. So what does 2x plus y equals 1 represent? x0 y1, x0 y1, cool. Y0x minus half. So y0x minus half. So basically we are getting y0x half, y0 and x will be half. So basically we are getting this portion of the graph. Okay, so let me color it. So this is the portion that I am getting above under this condition, x plus y greater than 0. X plus y greater than 0 is this region. So in this region, the portion of graph that we got, the hashed diagram, which you can see over here. Now we're left with y less than minus x, means below this. So for y less than minus x, this will open as negative. So that gives you x minus x plus y equals 1. And that evaluates to y equals minus 1. Y equals minus 1 is a point. So let's say this guy is minus 1. And now we have in this region y equals minus 1 look like a horizontal line, right? But remember, I am interested in x greater than 0, or you can tell x greater than equal to 0. So finally, the graph that we are getting is basically this portion of the graph over here, right? What about this portion? So can we extend it? So slope wise, since we know the slope of the line 2x plus y, so now let's draw in a proper way. So its slope is y equals minus 2 x plus 1, it's minus 2, whereas slope of this guy is minus 1. So that will be more slopey somewhere, right? Hence, if I plot 2x plus y equal to 1, we can clearly see the point. We can clearly see the point 1 comma minus 1, 1 comma minus 1 satisfy this equation. It means this point will definitely lie on the line to x plus y equals 1. So we can plot it roughly like this. And that's all. Now we'll reflect this graph along y-axis, and the final answer that I'm getting is this portion of the graph. So this is a portion that we got for x greater than equal to 0, and now the point was to reflect it over y-axis, and exactly we have symmetric. So that was so cool. So we have 0 comma 1, and then 1 comma minus 1, and we have minus 1 comma minus 1 over here, right? So this is all about the graph that we got, and it's nothing but a triangle. And that's an interesting thing because J can ask you find the area of the triangle given by this curve, right? So you can find half into base into height, and that will solve the question. Now let's do something more exciting, right? Because this was a simplest phase. Because finding a general equation that will describe any triangle, not only those with vertices as convenient grid points, is harder to approach, right? Because here symmetricity was there. So what if I have a general triangle anywhere? Let's say we have a general triangle ABC, and how with a single equation I'm going to capture the feeling of this triangle. So in order to do that, what we can do is we can invite a complex numbers, and that I feel it's quite a crazy way of doing this. And before we go further, I'll just recap how a line will be represented in complex plane. So let's say if z is a complex number and p is any other complex number c, so z bar p plus z p bar equals to, that will represent a line not passing the origin. Let's see why. So if I represent z as x plus iy, and let's say p as some a plus ib complex number, so this is going to be x minus iy times a plus ib plus x plus iy into a minus ib. Even last year J Advanced has asked similar question. So this is a hallmark of line in complex plane, right? So that gives ax plus by, and we'll have I times bx minus I times ay plus ax and plus by minus ibx plus iy equals 2. And successfully we can cancel all these guys. So we are left with all real terms. Ax plus by 2 copy equals 2, so that will give 1. So clearly it's a line, and 0 comma 0 does not belongs to this line, right? So it's a line on passing through origin, and depending upon value of a and b, it can represent any line. So this is the equation of line in complex plane. Now maybe some of you might feel like, why all of a sudden I wrote this equation? Because triangle is basically union of 3 line segments, so probably we can do something about this, right? Sometimes we can also, like, before I go to the generalized case, we can represent equilateral triangle in a complex plane. So let's say if you have 3 complex number, which you must have seen in your estimate textbook, UVW. So UVW is in complex plane C3. C3 means C belongs to complex number, C cross C cross 3, right? So usual, typical, beautiful set notice. So now I'm interested in finding a condition for which they form an equilateral triangle. So all of you know they will form equilateral triangle if and only if, and that's very important. So converse of this statement will also be true. I'm going to prove it right now. Q square plus b square plus w square is ub plus bw plus w. One of the student did proof of this in class like this. It also this can be written as u minus b whole square from class 8, u minus w whole square, and u minus w whole square half times of this. The given expression can be recasted in that fashion, and this equal to 0 will imply this 0, this 0, this 0. No, that's completely wrong. That will be fine if UVW belongs to real world, but here UVW is complex number, so you can't give the argument that this 3, the equation represented by this represents just a single point. Either UVW is equal, and that's the only thing. Okay, so that's completely wrong concept, because if you are in real world, then this will imply a equal to b equal to c, but in complex world This represents a very interesting situation. It's also implies, so this will be implied if and only if UVW you are in real world. But this will imply, interestingly, mod u equal to mod b equal to mod w, right? Like UV, in fact, this will implies mod of u minus b equal to mod of b minus w equal to mod of u minus w. So again, some equality sense is there in complex work if UVW belongs to C3. So let me quickly prove this. To establish this result, we need to undertake an analysis of relationship between these variables. One strategy is you can go in a reverse way, like you can take equilateral triangle, use rotation and Lemie's theorem, Coni's theorem, okay, and then you can go about it. The other way is without loss of generality. What you can do is uh, what about transformation? So without any loss of generality, let's say if we have triangle anywhere, so I can always shift origin to one of the vertices of a triangle. So that makes one complex number to be 0, right? So let's say if you have this complex number UVW, what I am doing is shifting of origin or relative velocity with respect to physics. So if I am subtracting u from all this, the relative configuration will be invariant, right? So this complex number turns to be 0. We have a new complex number, let's say v dash, and this is u dash. So now if I can show like corresponding to 0, u dash and v dash, if the relation holds. So we have now again three complex numbers, 0. So 0 square plus u dash square plus v dash square. If I can show 0 u dash plus u dash v dash plus 0 v dash. If this represents an equilateral triangle, it will implies our UVW is also representing an equilateral triangle in C3, right? So how to go about it? So now we can tell like u dash plus v dash square equals u dash v dash, which amounts to u dash plus v dash minus u dash v dash equals 0. Clearly this was a square. So u dash by v dash whole square minus u dash by v dash plus 1 is 0, provided I am not taking v dash 0. Of course, if we'll take v dash 0, one of the solution is u dash 0 or 1, so that we are excluding. So under this situation, I know the root of this equation will be minus omega and minus omega square, right? So I can tell u dash by v dash will be either minus omega or minus omega square. So u dash by v dash argument will be argument of minus omega, which is argument of minus omega is what? It's minus 2 pi by 3. And if I'll take mod on both sides, so mod of u dash by v dash is mod of minus omega, which is nothing but. So I know origin, which is 0, complex number 0, and u dash and v dash is such that they are at the same distance from origin. That's the first implication out of their mod to be equal. And the second implication is argument of u dash minus argument of v dash, which is arg of u minus v, is minus 2 by 3. Okay, so that fundamentally is if we have what we can tell is argument of minus omega can be written as, because omega is over here, right? So this is theta. So what is, where is minus omega? Minus omega is over here. It's just reflection about origin. So this argument is minus 60 degree. Okay. So, or in other words, you can write this as argument of minus 1 plus argument of omega. Argument of minus 1 is pi, and that is plus 2 pi by 3. So that goes to be 4 pi by 3. Is 2 pi plus pi by 3. So it's basically 60 degree, right? Like minus 1 will give you minus pi. Extremely sorry for that silly calculation mistake. So it's minus pi plus 2 pi by 3, which gives, yeah, as usual, minus pi by 3. Okay, so anyway, the angle, because minus pi by 3 just shows the orientation of angle is in opposite direction, but the magnitude of angle between u dash and v dash is 60 degree, right? Since I can tell u dash, v dash and origin forms an equilateral triangle here. So that was a beautiful proof, and you can see the single equation, this equation packages an equilateral triangle in itself. So this implies this. Okay. Uh, there was some problem in JEE Mains, which was motivated by this idea. So the third way of describing now come to the most general solutions, and the most interesting way of describing a general triangle will be probably via the distance or probably via line segment. So if I ask you, let's say if you have a complex number Z1 and Z2, how will you describe this line segment, right? So well, there is many way of describing this. One way is maybe I can tell Z such that is Z1 plus T times of, we can define a vector Z2 minus Z1, okay, where T belongs to 0 to 1. So this precisely picks up the section formula. So let's say if I keep T equals 0, I'll get Z at Z1. For T equals 1, Z counts to be Z2, and so on and so forth. You can put T equals half and you get exactly Z1 plus half times Z2 minus Z1, which gives you half Z1 plus Z2. So T half is exactly the midpoint over here. So like this is like a pawn on the string, you keep on changing T and you'll get, okay, a line segment captured or truncated between Z1 and Z2. Well, is there any other way of putting the same information? Yes, there is another cool way in which you can put the same uh, feeling, and that's very interesting. So what I can tell is, let's say what about Z minus Z1 plus Z minus Z2 and minus Z1 minus Z2. If I consider this expression, let's say make it 0. So what about the locus of Z such that Z minus Z1 mod plus Z minus Z2 mod equals Z1 minus Z2 is precisely the same line segment, because we can consider two complex numbers Z1 and Z2 as follows. And now according to the question, Z minus Z1 is distance of Z from Z1. So we want a Z such that is distance from Z1 plus is distance from Z2 should be equal to distance from Z1 and Z2. And precisely Z had to lie on the line segment. Okay, so I'm going to use this basic idea to describe, uh, like triangle. So let's say if I define S as the set of all Z such that the mod of, let's say, Z plus I minus 1 plus mod of Z minus I minus root 5 times Z plus I plus 1 mod Z minus I minus root 5 times mod of Z plus I plus 1 plus mod of Z plus I minus 1 minus 2 equals 0, then precisely the points in set S forms a triangle. Now why it will form a triangle? Because you see, if this entire quantity is 0, so either this guy will be 0 or this will be 0 or this will be 0. So now first you can clearly set distance between I minus 1 and I, which is 1 minus I, and I is root 5. So first expression I can decode as Z plus I minus 1 plus Z minus I equal to root 5. What does this locus make? Okay, let's see. So this represents distance from a complex number iota, and this represents Z minus 1 minus I. So we have 1 and minus I somewhere here. Now what is the distance between 0 comma 1 and 1 comma minus 1? That's basically 1 minus I and I representation in Argand plane. So this distance is nothing but simply is root 5, right, which is precisely given over here. So that represents a line segment connecting, let's say, point A and B. Similarly, if we'll decode the other two parts over here, so that will represent another line segment connecting minus I minus 1 comma minus I, which is minus 1 comma minus 1, and that will represent another line segment, right? Similarly, the third one represents line segment connecting 1 minus 1 minus 1. So we have again the same triangle as I started the session with in a complex number language. So set S describes the triangle mod x plus mod y plus mod x equals 1. I think that was the beginning of our session. Coordinated style. So in a coordinate free world and in a complex world, you can describe the same equation in this fashion. Now the triangle is definitely, we can generalize this for polygon as well. So let's say if I give you the set of all x, set of all z, such that product of k equals 1 to n mod z minus ak plus mod z minus ak plus 1 minus mod ak minus ak plus 1 equals 0, where all these ak and ak plus 1, let's say complex numbers. Now when I tell complex numbers, so every real number is complex number, even 1 is complex, 1 is complex number, right? 2 is also complex number, and that's purely real, purely imaginary. That's another way, because this is real world, so complex world is superset of real world, right? So real number is a subset of complex world. So this will represent a polygon, okay, with so this 0 will represent set as, it represents polygon with a1 a2 an as vertices. So I guess you have enjoyed this, and that's very interesting way of defining this. So similarly, you can try by your own and try to use a complex number notation to describe this equation, mod x plus mod y equals 3, which will look as something like Kaju wala barfi. X0 will give y plus minus 3, y0 will give plus x plus minus 3. Okay, so most of the problems of mains and advanced in the upcoming sessions will be motivated by this, and I'm sure in your January session, some of the ideas, if it matches, you should not be surprised. Okay, so I hope you are enjoying this. In fact, there is something more to this. Okay, in order to build our equation of triangle, what we use is complex numbers, and the range of functions is including absolute value functions. Okay, and what we have seen is we use implicit functions to create equations, and complex numbers to abbreviate and clarify and synthesis, like basically to separate conditions. However, the use of absolute value function, the way in which we used it, mean the resulting equations are probably difficult in practice to manipulate algebraically into alternative equivalence form, right? So there are, I guess, a lot of situations in which functions with particular properties is created in that cosmetic fashion. And if I could correctly recall, in 1964, Williams from the University of Birmingham, he gave a nice formula for nth prime number. An explanation of this formula was recently given by I guess some of his YouTube channel. Okay, so like he gave a cool formula for prime number, which if you want those who are just interested for the beautiful mathematical sake, so nth prime number, what he gave is 1 plus sigma m equals 1 to the power n, nth root of n sigma x equals 1 to m cos square by x minus 1 factorial plus 1 by x to the power minus 1 by n, right? And this I was reading one of the paper journal from where I got it. Clearly, like, there is a breakage to this, so it's not like it will be valid for nth prime number calculation up to 2 ka power n, which is catastrophically inefficient for even modest prime, right? But yeah, it's quite plenty of examples where Pn will give you really nth prime number, but not for all. Okay, none of these formula for nth prime number are useful in any computation situation because they are all too efficient to calculate. However, they are theoretically interesting, and they form another collection of functions which looks very complex in the first acquaintance, but which have been synthesized carefully to have particular properties, exactly in the way we have done here for a triangle itself. Okay. So this was quite a glimpse of how mathematicians, like, perform a beautiful art on these triangles and polynomial. But at the same time, since this channel does not require any much prerequisite, that's why I will not go into much detail of it. So let's keep our content useful and more interesting for our JEE preparation as of now. until I come with some Olympiad sessions explicitly. Thank you. Have a good day. And if you're enjoying this channel, and if you want more mock test or in some particular topic, please do comment so that I can come with the ideas which will be helpful for you. And by the way, if some of you wants it to be in Hindi, which is more beneficial, because I guess some of our subscriber, they are not so well versed in Hindi, but mostly since you guys are into J preparation, so you are smart enough to understand the language. And moreover, our beautiful mathematics doesn't require any language barrier at all. Okay, so I don't think like language should be a barrier, or at least in understanding mathematics. And still, I'll try my best to use English in most of the videos. Thank you. Have a good day. Enjoy. Keep watching. Take care. Bye bye.